Hello, this is Professor Kyle Mack, and this is your 11-3 lesson intro in 5 minutes or less. Alright, so we're going to look at three key concepts: curves, polygons, and symmetry. So the first thing we're going to do is curves. A curve is a figure that is continuous in nature, so that way if you were to sketch something on a piece of paper, as soon as you picked up your pencil or pen, you have created a curve. A polygon is just a special type of curve. There are no overlaps, it ends where it starts, and line segments make up all of its sides. So a circle is not actually a polygon because it doesn't have line segments making up all of its sides. Then we have symmetry. The ability of a figure to repeat an overlapping image of itself is what we call either line symmetry, point symmetry, or turn symmetry. And we'll look at the different definitions for each of those. Okay, so let's look at some concepts related to curves. So you have the concept of being simple, closed, a polygon, convex, or a concave curve. A simple curve is one that does not overlap itself. A closed curve is one that ends where it started. A polygon, as we've talked about beforehand, is simple, closed, and its sides are all line segments. Then a convex curve is one that has no inward angles. So notice all of these angles go outward, but a concave has at least one angle that does go inward. Now let's look at key ideas about polygons. The first is that there are regions to a polygon. There's the interior, exterior, and then the polygon itself. So your interior is colored in blue, your exterior is all the space outside of the polygon, and then the polygon itself is just the line segments connecting together. This is important in math because if I had a line that intersected through the polygon, that actually only intersects the polygon itself at two locations. The interior of the polygon has much more overlapping, but if you're just asking for where it intersects the polygon itself, you only give those two locations. The next thing is names of polygons are based upon the number of sides. This is something that you should be familiar with. A triangle is named a triangle because of its three sides. A quadrilateral is four-sided. A pentagon is five-sided, so on and so forth. A line that connects one vertex to another non-consecutive side is called a diagonal. I have a picture of a pentagon here that has a vertex going to an opposite vertex, and here's another one that's going to a different vertex. And so to understand the concept of a side, that would be like this right here. This is a side, and this is a side, and those are consecutive sides. But these are non-consecutive sides, and so therefore those vertices can actually have a diagonal connecting to them. There are actually 5 diagonals in a polygon, or I'm sorry, a 5-sided polygon, which is a pentagon. A polygon with congruent sides and angles is called regular. This polygon right here is equilateral, meaning all of its sides are the same measure, and is also equiangular, meaning all of its angles are of the same measure. And so therefore this is a regular pentagon. Finally, 3- and 4-sided figures each have a special subcategorical naming system. Let's look at triangles first. Triangles are either equilateral, isosceles, or scalene. These are their lateral or side measure naming system. And then finally you have acute, right, obtuse, and that would be related to their angle measures. And then we have the 4-sided figures: parallelograms, rectangles, squares, rhombuses, trapezoids, and kites are all different types of 4-sided figures. And then we get to our key ideas about symmetry. So here are your 3: line, turn, and point. A line creates overlapping images based upon a fold line, which we call the axis of symmetry. Then we have turn symmetry. That's the ability to rotate a figure and create an overlap. Finally, we have point symmetry. When the turn symmetry is 180 degrees, or you can have a combination of multiple turns that create 180 degrees, like a 90 to 90, then we call that point symmetry. And that is your 11-3 lesson intro in 5 minutes or less.